So rule number one, if you want to multiply matrices, those middle numbers have to be the same when you put the dimensions beside each other. Rule number two, if they are the same, your answer is going to be the outside will be the size of the answer. So one of the ones that I wrote for you the other day was taking, we did B times C, it was taking C times B. And I take C, its dimensions are 3 rows, 2 columns, B, 2 rows, 3 columns. This answer is going to be a 3 by 3. And I have 9 numbers to put in there. Everything is related to rows and columns. So I'm going to pick some numbers, and I'm going to take a different color here. Let's say I look at this one, this 24. This 24's position is in row 3, column 2. Row 3, column 2 is the position of that 24. If I would look at my original C and A, if I would look at row 3 and column 2, is there any way you could come up with 24 with those numbers? Okay, you're like, ooh, it's 6 times 4. I see a 24. Okay, so we get an idea. I've got a way to get 24. Let's look at a different number. Take out orange. How about this one? Row 2, column 2. I'll do that in orange. No, I don't want. I'm actually going to switch to this one. Okay? Are you okay? Just because sometimes zeros make your brain do weird things. They don't help you very much. Because in this one, you could just say, oh, it's just 6 times 4. But then if I took row 1, here's row 1, and I take row 1, column 2, oh, I use the 0 again.
Is that backwards, or is that row 2, column 1?
It is row 2, column 1. That's good. Thank you so much for pointing out my inability to think this morning. Yes, I know it's this afternoon. Okay. Here we go. We're going to circle this correctly. This is in row 2, column 1. We would go to C, we would go to row 2, and column 1. We're good here. Now, can you come up with a way of getting 1 using row 2 and column 1? Okay. I'm going to circle another one in a different, here's one that doesn't have zeros. B doesn't have zeros in row 1. I'm going to circle this 6. And I want you to see if you can come up with row 1, column 1 from B and C. Okay. Now, I'm not going to get you to tell me the pattern that you see if you see it. But if you think you have an idea, I'm going to go to C and B and start with row 1, column 1. And you can take a guess what you think that number should be. What do you think? 2. That is correct. Okay. Next, you've answered one, so you can't answer again. You can do it in your head. You can see if you can figure it out. We're going to go to the second one, which is still row 1, but column 2.
-3.
No, it's not -3.
-2.
It's -2. There it is. 2 people who've answered one. Keep looking for patterns. We're going to go row 1, column 3. See if we can figure out what that answer would be. And as we add ones to our answers, it gives you more hints. It is 1. Whoa. Okay. All right. Some people are smirking because they feel like they got it. Other people are kind of like, I want to punch that person because I haven't figured it out yet. All right. Let's do this one. Let's see if we can figure out row 2, column 1. Row 2, column 1. We're looking. I'm just filling in this one. That's the one I'm trying to figure out now. We're doing it's C times B. So if we're row 2, column 1 is the hint, right? You're going to use row 2 from C, column 1 from B, and somehow get a number. Three people that answered it already feel like they have an answer for this one. What I'm going to do right now, sometimes these extra circles, can get confused. I did it again. I know. I feel like when I undo, okay, I didn't get rid of all my stuff. The purple box came back. That's what I want to do. Just get rid of some of these extra colors so we can look. I know what I'll do. I'll use my magic pen that disappears. So we can think about it just temporarily, but it won't ink up everything. So if I want to find C times B, and I want to find row 2, column 1, those are the numbers I want to use. This row, this column. This row, this column. This row, this column. What answer will we get? -2 again. Oh, we got someone else who thinks they figured it out. Okay, now, back to the erasing pen. Row 2, column 2. Oh, this one's a little bit easier mental math. Love the 0 for mental math easiness. What do you think we're going to get? What disappeared? Any guesses? 3. So what's happening is that, now I'm going to actually highlight this one. I'm going to take row 2, column 3. And a C would be written first and B second. The way that I like to visualize this is you take your row, whichever thing's first, which is C, take that row, rotate it to make it into a column, and then crash it into this column. So if I took the -3, 2, and I rotated these, like, this is how I visualize it. The -3 would be on the top, the 2 would be on the bottom, and then I crash, boom, boom, into those ones. And when they crash into things, they multiply. What's -3 times -1? 3, and that would get scattered somewhere over there because of the crash. And then 2 times, I didn't see that. Why is that cursor? Is it -3? Okay, there it is. 2 times -3, that would crash into there, and that -6 flew way over there. And after a crash, you have to pick up the pieces So you put the -6 and the 3 together, and you would get -3. You're missing my crash analogy. Neil. He needs it. Yeah. Okay. It's a great video. I already said it's the morning. Made lots of math mistakes. Paused it for a bunch. Surprised my volume was even on. Who's not here? So let's dedicate this video to Andre. But I said, let's go to the calculator. And if you look on your calculator, above the X to the -1 button, it says matrix. So if you hit the second and that matrix button, you have a bunch of matrices all ready to go. And what you can do is you can go to edit, and we can edit A, and we can make A, look at this one. This one is a 3x2, so I can write in my dimensions that this is going to be a 3, enter, by 2, enter. And then it was 1, 2, is this how I wrote before? Is that how it was 1, 2, 3, 4, 5, 6? Yes. Nice. So that's my matrix A. And now it's saved as 1, 2, 3, 4, 5, 6. I can go back to matrix and edit. See how, now it says at A. At A, it now says it's a 3x2. I'm going to go down to B. I'm going to go to edit. I'm going to edit B. B had 2 rows, 1 column, and it was 7 and 8. And now, in my regular calculations, I can go second matrix and select A. And I can multiply that by second matrix and get B. And I get 23, 53, 83. So if you had to do a bunch of multiplications and adding all together, this could be very helpful. So we'll see in some real life examples where this might be useful and why multiplication is set up this way when we do. Because right now you'd be like, did somebody just come up with the weirdest thing possible for multiplying? Because if adding was just add the same ones, why not just multiply the same ones and make your life easier? That would have been like a great easy rule, but what is the purpose of this weird rule? Oh, you know what's really cool is sometimes you'll want to use these answers again. You can use your store button and go back to matrices and pick a matrix you haven't used, and it will then remember that as matrix C from now on. We'll store all those numbers in the right spots. Okay. So, second one here. Can we put these together? No. The 2x2 by 1x3, they are not compatible. So multiplication, these are very fun ones on quizzes and tests, because your answers you use right away. Not possible, no mental math needed. Yes.
Can you multiply more than 2 matrices together?
You can't. Because if you look at our examples, here we had A times B times C. Check it out. A was a 2x2. B was a, what was B? 2x3. And C was a 3x2. You see the middle numbers all are matching. And our final answer is a 2x2. Something to play around with. Does it matter? Do I have to do A times B first and then multiply by C? Or what if I did B times C first and then multiply by A? Would it work? You could play around on your calculator and find out. We already found out with matrices that matrices are messed up, that A times B and B times A is not the same thing. Rule 2, if we can multiply the matrices, then the dimensions are the outside number. So we have the 2x2, outside number is 3x1, We already calculated the 23, 53, 83. And so it tells you how many answers. And that's because for every answer, you have to take a row and multiply it by its column. And rule 3, we multiply a row by a column and add. So we take that 1, 2. I like to turn it sideways and crash it in there. Just, I don't know. Something about violence and math going together just seems like the right kind of thing to do in this situation. Crash them together, add up the pieces, and see what we get in the end. It's also just a nice visual. Just like I can just see it like it's like when you turn it, you kind of pull it back, and it's like it's on a spring load, and then you let it go and just crashes into the other one. Right? So 1 by 4 by 4 by 2 would definitely be 1 by 2. Can't multiply these. They're not the same. So here are A, B, and C. Let's see how many questions we have here. Oh, I had these answers up from before. I'll let you figure them out. I'll pause the video. Everybody see the answer for the first one?
I sent you a...
All right, there's the answer to C. How many people are done all of them? Most people? Okay, I'll show you the other ones. Oh, that was the easy one. That's not fair. A squared. One 0 14. 36. Can you see it there? It's easy to make small mental math mistakes in this unit. Yes. And A times B is there. And then times C. Would give us those answers. Did anybody do B times C first and check it? Well, I hate to, we could check it and you'd find out that it works because these, okay, we already found out that changing the order does not give you the same result. 5 times 3 and 3 times 5, in mathematics, we call that commutative. When you can do multiply one way and multiply the other way and they're the same. In normal math, multiplication is commutative. In matrices, multiplication is not commutative. But here are the rules and the laws for multiplication and some of the math words that go with it. Okay? There's commutative. Here is associative. It does work that you could have done A times B first or the B times C with matrices. So that's kind of interesting. You can distribute, right? So you know in regular math you distribute something when you have something in front here? It would work to do A times B with matrix multiplication and A times C with matrix multiplication and then add them up. But I'll tell you this much, the adding is easy. The multiplying is more complicated. I don't think you'd ever really want to do this unless there was some sort of strategy. Like, this would be the only, I can see, it'd be like, what is this? Then I'd be like, ooh, it makes sense. Because I could add these up, multiply times A, and then have to subtract and multiply those together. But if I distribute first, You're gonna be like, ooh, this will be the zero matrix and it's just A times B. So that would be a situation where like, okay, that property might actually save me some work, but usually more multiplication means more work. So I don't know if I would use the distributive property. And there's the identity matrix. Remember, the identity matrix is a square matrix with all ones along the diagonal. Check out what happens. I'm going to just take a 2 by 2. So let's just go 1, 2, 3, 4. And I'm going to take the identity matrix out in front. 1, 1, 0, 0. This 2 by 2 times this 2 by 2 will give me a 2 by 2 as an answer. Make sense? Because then this is a 2 by 2. This is a 2 by 2. Middle numbers are the same. Outside numbers are also 2. So we get a 2 by 2 as an answer. Take row 1. Rotate it. Boom. You just get 1. Take row 1. Multiply column 2. Take row 2, multiply column 1. Take row 2, multiply column 2. You get exactly the same thing you started with. This is what an identity is supposed to do. In mathematics, whatever mathematics you're using, you like to find the number 1, right? Because then you can be really impressive and say, I know my 1 times table, right? Test me. Give me a big number.
What is 1 times 725?
725. See, and you can be like, impress your friends with your great skills at multiplying by 1. So in every math, there is a multiplicative, well, not every math, but if you can find it, it becomes very important. Because if you have the identity is equal to 1. In matrices, there's no dividing. We don't have dividing in matrices. But instead, we multiply by an inverse. And if you multiply by an inverse, you're going to get the identity matrix. And this is going to be a very important thing for us solving equations and doing math. It's kind of like dividing. But instead of dividing, we find an inverse and multiply by it. So this is the question. Let's see if you can figure out what I could put here to get this. That would be my inverse. There's lots of possibilities. Let's make something work, and then we'll like have problems with that, and make something else work, and then we'll have problems with that. Like, for example, if I wanted to get this to be a 1, I could just have 1 and 0. Did that not work? Okay. All right. And if I want this to be a 0, well, maybe I make this -2 and this 1. But now I check. Does that still give me 0? Oh, no. I erase it and I start again. Guessing and checking could take us a long time. I mean, possibly we could just go A, B, C, D, and if we can make 4 equations with 4 unknowns, we could solve a very big system of equation, right? Because I know that A plus 2C has to equal 1. And I would know that B plus 2D has to equal 0. And 3A's plus 4C's has to equal 0. And 3B's plus 4D's has to equal 1. And I could just solve that system of equations. Which doesn't look like very much fun, but would be doable, right? Have you ever, you've done 3 equations with 3 unknowns. Have you ever done 4 equations with 4 unknowns? You'd have to like slowly eliminate a variable till you get to 3 equations with 3 unknowns, then eliminate another variable to get 2 equations, 2 unknowns, and then find one of those things, and then work your way all the way backwards to find your answer. We're going to be able to find our inverses without having to do these equations once we notice some patterns. So there's an inverse, and inverses are going to be helpful for solving equations. Okay. Do we have, you know what? Yeah, we'll end our video here. And I've got a worksheet for you.